Alright, now we will deal with sample problem 5.5. A woman pushes a 2 kilograms cart initially at rest with a force of 350 newtons along a horizontal surface. The cart moves a distance of 4 meters. The question is, what is the final speed of the cart, assuming it starts from rest? So let's first have the summary of the quantities that we are going to deal with. Now we have here mass, which is 2 kilograms, force 350 newtons, distance 4 meters, and we have to find the final speed. Okay, so for the solution, we are going to solve first the work done, which is in equation W equals Fx, and then right after that we are going to deal with equation 5.7. So let's start. Okay, so for the work done, we have W equals Fx. F is 350 newtons. Multiply that to 4 meters. We get 1,400 Newton meter or joules. Okay, so from here, since we are going to find the value of V, or the final speed, we need to use equation 5.7. So equation 5.7 is W equals K minus K sub 0. W here is the work done. K here is the final kinetic energy, and K sub 0 here is the initial kinetic energy. So kinetic energy is expressed as 1/2 mv squared. So final mana. Next we are going to start with the manipulation of the equation here. We have this one already. You might wonder why we are talking about speed here, and then our equation involves letter V, which is oftentimes used for velocity. So before I told you already that velocity, or V, the what do you call this? The variable V is interchangeably used for speed and velocity. Okay, so let's begin. In this case, our initial speed is 0. So square of 0 is still 0. Multiply that to m, or the mass, and then 1/2. We will still get 0. So what will happen to the equation is it will become minus 0. Alright, so from here, since we are looking for since we are looking only for the speed, we have to divide both sides by 1/2 m. Okay, cancel. So we get W over 1/2 m, or 1 divided by 1/2. We will get 2 W over m. 1 divided by 1/2 is 2. That's why we have 2 there. And then since we have here the square, we have to extract that by, okay, that is how we get 2w over m, or square root rather, or v equals so v equals square root of 2w w over m. Substitute. W is 1,400. Joules over mass, which is 2 kilograms. Okay. 2 times 1,400, we get 2,800. Or we can just cancel that directly. $37. Square root of 1,400 is 37.42 meters per second, or approximately 37. Okay, how did we get meters per second? So as for the unit, square root of joules per kilogram. So I'm going to show how we came up with meter per second, or the unit meter per second. So this is from our answer, which is 1,400 joules per kilograms. So we're only focusing on the unit here. Alright, so joules here is the same as Newton meter. And the Newton meter, Newton rather, is kilogram meter per second squared. So mao ni siya si Newton. Since we multiply that to another meter, kani siya, that will become kilogram meter squared per second squared. So this one right here is already joules. Okay, so joules is kilogram meter squared per second squared divided by another kilogram. So we can cancel this, cancel. Square root of meter squared per second squared is, ano naman meter per second. So that is how we came up with the unit meter per second in our solution. Okay, so for sample problem 5.8, we have a 50 kilogram boy wanted to get a coconut from the tree. He can do this in two ways. First is he can climb the tree, or second is use a ladder of length, which is given as 12 meters and inclined 30 degrees with the horizontal. The height of the tree is 6 meters. Now find the work done by the gravitational force on the boy on each case. So we are going to deal with two cases. Okay, so I'm going to show here the diagram. It is already in the book, but since I'm going to use this in the explanation. So, magpasikat sa og drawing, but do not expect too much because your teacher is just pretty but not artistic. Yeah. Okay. Okay, alam sa mani. Wala ka dira. Wala ko na siya coconut. Sure ni. Ay, nako. Okay, so this is the coconut tree and this is the ladder. Okay. So this ladder right here is, I'm going to put the given here. So first is the mass of the boy, which is 50 kilograms. And then the length of the ladder, this one, that is 12 meters. So F here is the gravitational force. When we say gravitational force, that is just the same with weight. So since we are only given here the mass, which is 50 kilograms, we have to multiply that. How do we get the weight? We have to multiply that by 9.8 meters per second squared, or the acceleration due to gravity. Okay, we have weight, small w, stands for weight, and then displacement, cosine. Since this is the first case, our theta here is 180. Why is that 180? That is because the weight is directed downwards, right? The weight of the boy, if he climbs this tree, his weight is, or even if he doesn't climb the tree, his weight is still the same. Okay, so his weight is directed downward. And then the displacement is directed upward, since he is climbing up, meaning from this point he's going upward. So let's have blue for the displacement. Upward ang displacement. Now as you can see, the weight and displacement are directed in perfectly opposite directions. Our equation here is FD cosine theta, and theta here represents the angle between F and D, or the force and the displacement. In this case, we have 180 degrees because they are directed perfectly opposite from each other. That is why we get 180 degrees. We are focusing on the angle here between the force and the displacement, not just the figure of the tree. So weight is, how do we get the weight? Again, 50 kilograms times 9.8 meters per second squared, cosine 180 degrees. So 50 times 9.8. Oh, I forgot the displacement. I'm going to do it again here. So solution we have for the first case. Okay, so 50 times 9.8 is 490 kilogram meters per second squared. Multiply that to 6 meters, we get 2,940 kilogram meter squared per second squared, and then multiply that to cosine 180, which is equal to -1. Ako na lang ibutang dire. Is negative 2,940 kilograms meter squared per second squared, or (2,940 joules downward. Okay, so for the next one, or in using the ladder, okay, we are going to use the same equation from equation 5.1. But as you can see, the theta there is 120. Why is that 120? Okay, again, why is that 120? That is because we are dealing with an inclined plane here. So this is inclined at 30 degrees. You can go back to the previous video that I have, where I have discussed the work done on the gravitational force sa sample problem 5.1. But anyway, we can have it again here. So ano siya illustration, ha? Ano siya inclined plane, ano siya ang ladder kunuhay. Our angle is 30 degrees. And so if the boy climbs up here, he will get, or the gravitational force, okay, you will be directed this way. Dari for example ang area, and then the displacement is towards that direction. So if ato ni siyang iyana ipadayon dire, we will have to find the angle between the displacement and the force, right? So this angle right here. Okay, so since this one is 30 degrees, we can tell that its opposite or alternate angle is also 30 degrees, since these are equal. Okay, which is, if we extend this line, we can also get 30 degrees here. So 30 degrees, so this extending line right here, we can take this one as this, the displacement, or the line of the displacement, because they are parallel, so we can get the same angle for these lines here. So since this is 30 degrees, we add that 30 to the 90 degrees here, we will get 120. Same with the angle right here, since this line is parallel to this line, so this angle, which is 120, is the same as this one. That means the angle between the displacement and the force is equal to 120 degrees. So for the solution, we have W equals FD cosine 120 degrees. Our force is still 50 times 9.8 meters per second, which is equal to 490 kilogram meter per second squared, or newtons. Parihara diri kay ang gihatag is ang weight ang mass raman. So same process pagkuha ni F. And then the displacement is the distance, or the displacement is the length of the ladder, which is 12 meters, then cosine 120. Alright, so multiply these three values here. 490 times 12 times cosine 120, we get negative 2,940 joules, or 2,940 joules still downward. So for two cases, the work done is the same. We have 2,940 joules, or in the book it is approximated to 2,900 joules.